Hello everyone, let's take a look at LeetCode 81, searching rotated sorted array 2. So it's a follow-up of LeetCode 33, searching rotated sorted array 1. And for this problem, if you haven't finished LeetCode 33, you can practice that first, then do this problem. Okay, let's take a look at this problem. So the biggest difference is that in LeetCode 33, all the numbers in the array are unique, but for this problem, there can be some numbers that with same value. For example, in this example, 2, 5, 6, 0, 0, 1, 2, there are some repeated values. If we want to check if target is in nums, we know target is 0, then we return true. If target is 3, 3 is not in nums, so we return false. Okay, first, let's assume odd numbers are unique and go over the solution of 33, then extend 33 to this problem. Okay, if all the numbers are unique, we know there are two cases in general. The first case is this one. The increasing, there are only a few increasing values, then we go to the smallest value, then the large increase. For this one, on the contrary, at the beginning we have a large increase, then we go to the smallest value, then there's a small increase here. So by looking at the middle value, we know which condition. Like for this one, the middle value is smaller than the left, so we know it's this condition if the middle value is smaller than left. Then if target is within middle to right, then we know we should search right, otherwise we search left. For this case, we know mid is greater than left. So if target is within left to middle value, we search left, otherwise we search right. So every time we can drop half of the elements. The algorithm is log n. But for this problem, there's some same values. So mid is not always smaller or greater than left element. For example, array is 7, 7, 7, 7, 7, 1, 2, 7. It becomes this. It's a long flat line. Then we go to smallest value, so some increase, then flat line again. Another example, there is still a flat line. Then we increase a little bit, then we go back to the flat line. So for these two example, the middle value is same as left, also is same as right. So we cannot determine, or we cannot deduce anything from these three values since the three values are same. So we don't know like what the graph looks like. In this case, we cannot drop half the elements since we don't have any information. The only thing we know is that if target is left, then we can return true. Otherwise, we can only move left by 1. So we can only move step by 1 instead of half of the element. So the updated code is like this. All the code are exactly the same except here. So previously we have if else. Here we if mid is smaller than the left value, we know this is the first condition. Otherwise, if mid is greater than left number, this is the second condition. Else, we know it's pretty flat. We don't have any information. What we can do is to move the left by 1. So in the worst case, all the elements in my array are same. So in this case, we can just do a like binary linear search. So it's ON. So this algorithm will be like degraded to the linear search. In the best case, all the elements are different. It will be in log n time complexity. So the time complexity of this algorithm depends on the context of the nums. Okay, that's it. See you next time.